So what we do in MS is we use the symbol digit modality test. So this is a substitution cipher. So what we do is patients take this test, classic test in MS, where they basically have symbols and numerals, and they back solve equations with symbol digit modality. And then we literally count how many correct, it's literally a score by numerals. And we saw in the original active group, by the end of the double blind, about a 5-point change on symbol digit modality in the actives versus placebo. And that was incidentally significant. It's interesting, though, because such an improvement of 5 points on SDMT, again, symbol digit modality test, is about the equivalent of somebody being able to go back and work again.
Hello, Rob. You are the CEO and president, and Mark, you are the chief scientific officer of Clene Nanomedicine. So welcome to Modern Healthspan, and thank you so much for joining us today.
Thank you. It's a pleasure to be here.
So Clene are developing a somewhat unique therapy, which is which uses gold nanoparticles, which I have not heard as a therapy before. Could you provide some background on Clene and where you came to this therapy from?
So let me give a quick introduction to Clene. So we founded Clene in April of 2013. So we've been doing this now for about 11 and a half years. This is all around technology that Mark developed, created, invented, and patented. I'll let Mark talk about it in a second. We'll come up with the clinical program after this. But Mark, first, explain to our listeners the origin story behind this asset I'm holding, which patients will drink orally. CNMAU8, 60 mils, they drink it orally every morning in our clinical programs.
It's a concept that was born in my head and my team's head. My wife is a medical doctor, former research and other faculties at a large U.S. institution. My background is engineering, physics, and material science. And one day we were discussing the mitochondrium and the inner workings of it, and I knew very little about it. And she provided me with some information where she gave me some electron energy transfer information, essentially spectroscopy coming from a mitochondrium. And that told me something about the energy levels. I worked my entire career in inorganic physics, solid state physics, but it's all about catalyzing reactions, making certain things happen. And when I saw the functioning of a mitochondrium from this perspective, I said, that looks like a lot of chemical reactions I've seen. Electrons are involved, and something you told me is electron transport chain. They're changing energy levels. I think we might be able to do something from solid state physics here, like perhaps make a catalyst that could perhaps interact with those electron energy changing states. And that was the birth of it. And if I'd have known more about biology, we'd have never done this because there were 1,000 reasons that shouldn't work. But that was the beginning of it. So my background is I've done things like armor for people and for tanks, and I've had my special top secret clearance in the United States for a variety of different things, including things you can't see that fly and turbine engine components. So nothing to do with biology, but it turns out physics applies, and so does material science apply in biology.
Excellent. And so the actual therapy is these gold nanoparticles, right? So could we go into a bit more detail on how they actually help? So they are improving the performance of the mitochondria. Is that correct?
That is correct.
Yeah. And how do they do that?
Well, if your audience is familiar with enzymes, you could think of our gold nanoparticle as acting like a mimic of an enzyme, except we don't have all of the baggage where an enzyme can be corrupted, not be able to find its target. Our gold nanocrystals have on their surface a large pool of electrons. So this gets into the quantum physics of making gold, which is something you think is inert because you have teeth made of it. But at the quantum scale, if you design these things to be the right size, the right shape, and most important, to have a clean surface, we had to invent a way to do that. then you can take advantage of the massive amount of electrons on the surface. And we designed these gold nanocrystals so that those electrons could interface with, for example, the electron transport chain in mitochondria.
Okay. Right. So it's improving the way that the electrons, because the electron transport chain is like extracting electrons from NAD and then moving the protons across the border of.
Oh, you're right on. Yes.
Yeah.
So the way to short kind of change it is we do help get protons from damaged mitochondrial systems out across that inner membrane so they can come back through complex 5 ATP synthase. And one of the ways that that happens is we're able to change NADH into NAD plus so that we can get the balance of NAD and NADH appropriate. And that balance is really important, not just for energy production, but all kinds of cellular signaling mechanisms, DNA repair included. And so we designed this gold nanocrystal that Rob held up a bottle of it that you drink. It's tasteless. There's, let's just round it off, a quadrillion of the nanocrystals in that 60 milliliter bottle that you take once a day. They get into your stomach, cross the stomach barrier, get a protein corona on them from the bloodstream, which includes serum albumin and some other things. So then this is where we got lucky, right? We shouldn't have done this because it was too complex. But we said, if we get lucky enough and we get the right protein corona and biological identity, we may seek out these spots of inflammation. Turns out that we do. And once we get there, we enter through an endocytosis, penocytosis mechanism, get inside the cells and get up and in and around the mitochondrium. And so as long as we're in the vicinity of the mitochondrium, we have the ability to help that NADH become NAD plus. And a catalyst in my old world of solid state physics usually doesn't go too far or too less. It just seeks out right. And when things are in balance, homeostasis in a cellular system, it stops doing things. So Rob will tell you about our toxicity profile, which is none. And the reason for that is our mechanism of action is completely different. We actually, the way to think about it is we're a tiny artificial version of an enzyme that helps a very specific chemical reaction. Turns out there's more than one, but the very specific chemical reaction of NADH into NAD plus. And it's a big deal because we're supporting mitochondrial function, which if you've got an audience that's interested in aging, yes, we've been focused on neurodegenerative diseases, but this balancing and helping the mitochondrial function by, kind of a natural enzyme mimic that's not a biological entity. And I should mention, by the way, everything that you're accustomed to for drugs, it's one and done. These nanocrystals, they come out the same way that they went in when they're excreted, and they keep doing this reaction over and over. So one nanocrystal can have a lot of biological impact.
Okay, thank you. There was a couple of questions I wanted to go back to in there. So, right, I had a look, and it made sense that it was impacting the NAD plus NADH ratio. And just one thing is that goes the wrong way as we get older. So I just, it certainly seems like it would be helpful for aging as well, actually.
Good observation, Richard. We would agree with you.
Excellent. So so I did think about the buildup of gold. So you say it comes out. Do you know what the half-life is on it? How long does it stay inside the body?
We do. Rob, why don't you take that one?
Yeah, well, let's talk about
body
too. So we see it getting to steady state, Richard, in about, and that's a moment. It takes a moment to get to work. That's just to be clear. So we see steady state in our human studies as well as the animal studies to take up to 6 months. And in fact, in the clinical studies that I'm about to review, you will see that we often say that patients need to presume that they take the medicine for 6 months to get to a steady state. And then it takes about 3 to leave. Now, on the safety side, over 700 years so far collectively of participant exposure, CNM-Au8 in long-term use, consistent long-term use. We have treatment duration up to 5.1 years in our compassionate use program, called in America EAP, which stands for early access protocol. So it's a special FDA permission of right to try for high medical need diseases like ALS. Mark mentioned that the side effect profile is nil. What he means specifically is we don't have a single related serious adverse event. That is, not a single clinician has assigned a serious adverse event to our drug from any of our programs that have completed, including a phase 2 in Parkinson, 2 phase 2s in MS, and 2 in ALS and EAP as well. And so back to Mark's point about excretion. So we're primarily hepatically excreted. The nanocrystal leaves unchanged is what Mark really was just to emphasize his point there. It does its job within the body as a catalyst and then leaves unchanged, primarily in the feces. And we do see full clearance in animal models.
So the trials that the indications that you're looking at right now, right? You've started with ALS, and I think you had a quick look at Parkinson's. You've also looked at Parkinson's a little bit.
So we actually started, first of all, with what's called a target engagement translational effort in Parkinson's and in early MS that was stable. So these were 2 different studies. We used 31-phosphorus magnetic resonance spectroscopy, which is to say a 7 Tesla powered MRI, to assess bioenergetic change. So in other words, energetic metabolite change in the brain of both stable MS people who were taking disease-modifying therapies and had no MS lesions for at least 6 months. And in the case of Parkinson's, symptomatic Parkinson's patients. So that showed target engagement, which is to say we learned definitively that our asset is getting into the gut, crossing the blood-brain barrier, and driving the energetic change that Mark just spoke to that the mitochondria requires. Now, just said slightly differently in the way I'm thinking about that is that your brain and mine and all of the human brains are about 3 to 5% of our body weight, but we are consuming nonetheless about a quarter of the daily energy needs to fuel and fund our central nervous system. So everything we do to move and walk and talk and eat and chew and breathe is necessary with bioenergetic metabolite change. And this includes nicotinamide endonucleotide, includes ATP. And so what these 2 Parkinson's and the MS study did is show that we can actually change in a statistically significant way after 90 days of therapy, the bioenergetic metabolite change, looking at NAD and ATP in the brain. Then what we did next was we commenced a visionary multiple sclerosis study. We called it visionary because the primary endpoint was vision change. Literally to take multiple sclerosis patients that were stable on their DMT, their disease-modifying therapy, and to see if we could improve their vision. That was relevant because in so many MS patients, about half, the lesions, the multiple sclerotic lesions, have compromised on their optic nerve, their ability for contrast vision. Now, about the same time we were planning the visionary MS study in multiple sclerosis, we did some preclinical work with induced pluripotent stem cells in an in an ALS model. And that drove tremendous interest with our asset in ALS. And we commenced around the same time of the MS study, 2 ALS studies, one in Australia called Rescue and one in America called Healy.
Right. So so you looked in the brain. Do you see any physiological changes when with these MRI scans?
Mark, do you want to talk about that?
Yeah, we did. So that was work we did at University of Texas Southwest, and over a 90-day period, using patients as their own baseline, we were able to track by magnetic resonance P36 magnetic resonance spectroscopy. We're looking for phosphorus, which is one of the energy components, ATP, right, a phosphate, and we were able to see dramatic changes over that 90-day period in the amount of ATP and other energy molecules. And it was dramatic. And it turned out some people that had too much, they were brought back to homeostasis. Some people that had too little, they were brought back to homeostasis, exactly as we had hoped and predicted.
The holiday season, while joyful, can be incredibly demanding. From hectic schedules to increased social obligations, stress can take a toll on our well-being. Magnesium plays a crucial role in managing stress and promoting relaxation. However, many individuals are deficient, leading to symptoms like fatigue, poor sleep, and increased anxiety. Magnesium Breakthrough from BiOptimizers offers a comprehensive solution. The unique blend of magnesium citrate, glycinate, taurate, and more ensures maximum absorption and utilization by our cells. By replenishing your magnesium levels, you can enhance your body's ability to cope with stress, improve sleep quality, and maintain a calm, balanced mood. It's a great gift for yourself or a loved one this holiday season. To experience the benefits of Magnesium Breakthrough and take advantage of an exclusive $10 discount, go to bioptimizers.com/modern and use promo code MODERN10. By subscribing, you'll secure a consistent supply while enjoying discounts and complimentary gifts. Thank you for your support.
Rob, you talked at one point about remyelination. Did I hear that correctly?
You did, yeah. So we've talked about this in the visionary study. So this is the MS study, and let's just explain that study for a moment, because you're correct that remyelination has been certainly a bit of the holy grail objective for so many drug studies. So what visionary is, I think it's important that I set back up the study for just a second. So originally we did a 48-week placebo-controlled treatment period, so nearly a year. And we enrolled stable, relapsing, remitting multiple sclerosis participants, and all of them had to have chronic optic neuropathy, so in other words, compromise of their vision, and they had to be on background disease-modifying therapies. So these were patients that were stable. They had to be 6 months free of any previous lesion, and the average actually was for 3 years. So they had no recent MS compromise from new MS lesions attacking their neurons, but they nonetheless had vision compromise. So what we did is we randomized them to either placebo or our asset, CNM-Au8. And again, when we say placebo in all of our clinical studies, I'm holding up again this asset. If I was to drink this 60 mils and I was blindfolded and I was drinking my water glass, I would not be able to tell the difference. It tastes like water because it is mostly water. As Mark can give a little bit more color to in a second. But speaking of color, no pun intended, you see that it's purple. So the placebo is simply purple-colored water. Purple-colored water is what we use as placebo in all of our studies. In fact, one of our early challenges was to figure out a purple food dye that did not have any taste whatsoever, so it could be unblinded in placebo studies. In any event, half the patients were on placebo, half of them were on Au8. We followed them for a year. The primary endpoint was trying to assess if we could improve their low contrast vision acuity. So what this is, for people that may be less familiar, when the MS lesion hits my optic nerve, I lose my ability for contrast vision. So in all low light conditions, I get vision compromised. Walking to the mailbox at night, reading a menu is typical. I'm in my late 50s now, so sometimes in restaurants, I need to pull out my cell phone to illuminate a menu if I don't have any reading glasses on. MS patients have to manage these problems all the time in low light conditions. And so literally what we did is used a classic Sloan chart, which is similar to an optometrist chart that one would see if I went to get a vision exam for my glasses or contacts. I literally look across the room at a defined prescribed distance and I read O, Z, D, V, K, Z, V, C, blah, 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 on the letters. And we counted the number of correct letters that folks could read. That was the primary. The secondary endpoint was a composite endpoint looking at fine motor control, cognition, my ability to walk 25 feet down a hallway, and my speed of that ability, and then vision. So I had 6 components on my secondary endpoint, 1 on my primary. And the reason we talk about remyelination is because we followed those patients for 2 further years in open label. So 12 months of double blind, then everybody had permission to roll into open label. 90% of patients chose to go on active drug. And then we followed the original placebos plus 2 years of active versus the original actives plus 2 years on original active. And what we saw is we did some very interesting work with visual evoked potentials. Now, what that basically means, again, this gets a little bit wonky, but we're understanding the speed and the amplitude of the signal when my eye sees this back to my visual cortex. So signal strength is amplitude, signal speed is latency. And we're evaluating that with a specialized device called visual evoked potential. And we're seeing both improved latency and improved amplitude. Now, if I improve my amplitude, that is associated with an improved axon integrity, meaning I can push more signal into my visual cortex. If I see latency, that is actually associated with evidence of remyelination. So a compromised optic nerve, if I have more latency, so more speed, signal speed is able to move down, it suggests faster conduction velocity and by consequence, remyelination. That's not the only thing that we did to assess this. We also tried to assess advanced MRI techniques. And what we did in that instance, same study, is we evaluated people during this entire 3-year period, again, 12 months of double-blind placebo control and 2 months of follow-on, and we looked at what's called their myelin water fraction with an MRI machine to understand the degree to which we can actually see more axonal integrity, less axial diffusivity, in other words. And by looking at the myelin water fraction with this advanced MRI technique, we can actually look into the brain and see if we can improve how patients are actually doing with respect to myelin water fraction. And in the cerebrum, we think we see evidence of remyelination therein. Now, all this study in MS needs to be repeated in a phase 3, which at the right time we are planning and will commence.
Interesting. Yes. I was going to ask you about cognitive impairment. So you actually looked at the cognition. Did you see any result?
Yep. So this actually is presently there's a slide on our website that any of your viewers can certainly go look at when we talk about this visionary study, but let me talk about it. So what we do in MS is we use the symbol digit modality test. So this is a substitution cipher. So what we do is patients take this test, classic test in MS, where they basically have symbols and numerals, and they back solve equations with symbol digit modality. And then we literally count how many correct, it's literally a score by numerals. And we saw in the original active group, by the end of the double blind, about a 5-point change on symbol digit modality in the actives versus placebo. And that was incidentally significant. It's interesting, though, because such an improvement of 5 points on SDMT, again, symbol digit modality test, is about the equivalent of somebody being able to go back and work again. In other words, their MS had caused cognition challenges such that they had, as one MS patient explained it to me, a cognitive fog, or he said cog fog. He just felt blurry in his head, and it caused compromise of his, daily activities of just cognition. And that 5-point improvement was quite significant. But what's more interesting to me is 2 things about this study. We then followed them, as I've said now twice, for 2 further years. And by the end of that 3-year total period, the original actives had improved about 7.5 points on symbol digit. So quite appreciable improvement. But the second piece that was equally impressive is the placebo folks that had not seen cognition improvement during that first year. We then rolled them onto active drug. After 6 months, when they started to get into steady state and flow blood levels of our asset, then they nearly replicated the same improvement that the original actives had seen. In fact, I've got a graphic showing both the remyelination and the cognition improvement on our website presently in our investor deck, if somebody wants to go see that. And we've also presented this at the American Academy of Neurology in April of this year, and there's a press release related to that. So in other words, this improvement, even though the patients had had functional compromise, despite full DMT tamping down their MS lesions, they were compromised cognitively, and AUA over the course of this first year and then 2 further follow-ups improved that cognition.
So you haven't looked at you may Alzheimer's or mild cognitive. Is there a reason for that?
Simply because we can't boil the ocean with this asset. So everything we've just done, CNMAU8 30 milligrams, is the MS, Parkinson's, and ALS work is all the same drug, the same dose. It is remarkably atypical in pharmaceutical drug development, as certainly you know, and probably most everybody listening, to have one asset be able to be used at the same dose, at the same time, taken orally in the morning, across different diseases that have a completely different series of insults that are attacking the disease, the body, and the central nervous system. We actually have hope and plans that cognition in Alzheimer's could be applicable, but at the meantime, we've really started, frankly, with the rare orphan disease ALS as our primary focus.
I absolutely understand that. Yeah, I mean, yeah, you got to focus. But although, just a thought on that, I mean, it's interesting. If it's improving mitochondrial behavior, that would impact many places in the body. I mean, it's not specifically the brain, right? We use muscles, and it would be interesting to see whether it would also improve physical performance.
Mark, you want to talk about the big picture in terms of that mitochondrial? Yeah.
I'd love to, and there's not enough time to effuse on it. But what you're hearing and what your listeners are hearing here is we've got a paradigm shift in nanoparticle design. Prior to it, why didn't somebody else discover this or think of it? And that's because anyone who ever tried to take an oxide or a carbide, or in this case, a metal, and suspend it in a liquid, have been focused almost exclusively on making sure that what's called a colloid is stable. And many people were very proud of the various surfactant chemistries that were placed on these various nanoparticles to make them stable. What was missed there is when you do that, you create a potentially moderate to highly toxic material. So prior to us, there were 250 publications, give or take a couple, that were out there, and half of them said gold nanoparticles were toxic. The other half said they were inert. They were both wrong. Gold nanoparticles are neither toxic nor inert. It has to do with the surface. So if you're like us and you understood this is a paradigm changing thing, you had to come up with not just a manufacturing process to do that, but we've totally transformed the way to think about, in this case, metallic nanoparticles. We're talking about gold just now, because gold happens to have very nice available electrons as long as it's a clean surface. Our company's name, Rob named it Clene because he expected a clean tox profile, and I loved it because we're the only ones ever to make metallic nanoparticles with a clean surface that doesn't cover up all of the catalytically active sites and doesn't spit into the body toxic materials. We're the first ones to come up with that. And we recognize the importance of the clean surface outside of biology and some of the other work that we'd done that preceded the formation of Clene. So we understood that in other chemistries in the solid state world. When that happens and you get clean surface, highly faceted metallic gold, pure gold, into the body, they're not toxic because they don't have any profile to exude into the body. And they're of the right nature. They can be an electron donor, an electron acceptor. Depending on the environment they're in, they're indifferent. They're trying to find homeostasis. I believe there's not a single neurodegenerative disease that what Rob had his hand behind will not benefit from, right? We have to prove that because there's regulatory authorities that say you can't just say that, Mark, you have to prove it. But Richard, you hit the nail on the head. If we have something that's ubiquitous that helps struggling mitochondria, for example, helping convert NADH into NAD plus for free and getting the right ratio. And there's no other person or company in the world that's ever said they can do that. There's supplements you can take that's equivalent to putting more and more gasoline into a broken engine in a car. Our nanocrystal comes along and we're just like this artificial helper that keeps the engine working. The cellular energy metabolism keep going. Remember, the nanocrystal, when it's local, it keeps working. It doesn't get used up after one exchange of electrons with electron transport chain. There can be literally millions of those exchanges in a single nanocrystal in a short amount of time. And Rob had in his hand something where you swallow a quadrillion at a time, and the dose is every single day before breakfast that you do that. And we're not certain if you're on a disease-modifying therapy like multiple sclerosis, if you'll forever have to take CNMAU8. Maybe there's a point in time where we've remyelinated, and if you're on your disease-modifying therapy, maybe you don't have to take it. In diseases like ALS, where the insult is just devastating, you may have to take it for the rest of your life, which our data says it's longer than if you were on placebo or not taking our drug at all. So, Richard, you're right on target, and I need to say this as well. In drug discovery, there's a lot of iterative process. There's a lot of computing. There's a lot of, oh, that didn't work, that didn't work. We set AMU8. My team set it based on physical parameters and math, and we had no biological experiments when we designed our device that runs by a novel process. And there's a lot of recipes by changing dials that you can make. We landed on one, and we did that with no biological experiments whatsoever. And every single biological experiment that's been performed by this company under Rob's direction, whether it was in a test tube the size of my thumb, or whether it was in Petri dishes, or whether it was in animals who were challenged, or whether it's in humans, we've been 100% successful. So that's applying the concept of physics, solid state physics, to biology. And again, if I'd have been trained in biology like I've learned now, I too would have never set out on this path. It turns out it took someone not in this to be dumb enough to try it.
Yeah, biology is amazingly complex. That is one thing that I am learning.
Sure
and
is.
it never seems to be like a straight line. You think, oh, well, that would make sense, and then in the end, that's not the way it works. But it's brilliant that it worked for you so far. So one question I had is, why is it purple in water? I mean, why is gold nanoparticles purple? Do we know?
That goes to the quantum physics of what you're seeing. So the light that you're in right now, natural or artificial, spans about 400 nanometers to about 800 nanometers. And it turns out, and it's a very, very important characteristic of our gold nanocrystals, that they will absorb a region of the visible light around 515 to 540, in that range. It turns out that if you go look at a chart, you'll find out that's roughly a green color. It corresponds to green. And so if you take the color green out of white light, you're left with purple. That's how you get that color. So when you have that color, it tells you it's active. If it's not that color, something has happened. Like, for example, a contaminant has gotten into the bottle. If it's not that color, something bad has happened. That color, by definition, tells you the drug is ready to go and ready to react.
Okay. So you talked, Rob, you talked about the phase 2 trials that you have been through.
Yeah, so
where are you going? I think you've got a phase 3 planned, and yeah.
So I talked about MS quite at length. Let me talk about ALS now too, because I mentioned that was our focus. So we completed studies, Rescue and Healy. The Rescue study was a 9-month-long program, phase 2 in Australia. We did it at 2 of the key centers of excellence in the city of Sydney there, with Dr. Matthew Kiernan and Dr. Steve Vucek. And that was looking over 9 months as to whether or not we could improve function. The Healy program was actually originated because of that data that I talked about earlier. When we did an induced pluripotent stem cell model, the Healy team saw this data, and amongst many entrants, more than 30, Clene's CNMAU8 was chosen for the Healy platform study, which is arguably one of the more important ALS clinical programs yet attempted. What platform means is that multiple drugs are assessed somewhat head-to-head. Now, it's not truly head-to-head. Everybody has the same inclusion criteria, the same exclusion criteria. They all are assessed in the same time period, 6 months, and they're all assessed with the same endpoints. And so far, the Healy program has concluded 5 different drugs Of these five, all five missed the primary endpoint, including Clene, but only one, our drug, achieved its secondary endpoint of survival, and only one, our drug, achieved in the exploratory program clinical worsening benefits, which is to say that we delayed time to clinical worsening. And that in ALS is massive. Clinical worsening in ALS is defined as whether I die, an obvious marker of clinical worsening, whether or not I need a full-time breathing support called PAV, permanently assisted ventilation, to breathe for me because my lungs can no longer power my breathing, or whether my lungs are becoming so exhausted that I need supplemental breathing, or I can no longer swallow food or water, so I need a gastrostomy tube. So that is all very much evident to every listener, clinical worsening. So we are the only one to show in the double-blind period a statistically significant clinical worsening benefit. And finally, we are the only ones to also see a neurofilament benefit in the double-blind period. So neurofilament is a biomarker. As the ALS disease attacks the neuron, it leaves cytoskeletal remains in the blood and in the CSF that we can measure. It's a biomarker, not, it's like glucose in my blood if I'm a diabetic would be a biomarker. Cholesterol in my blood would be a biomarker if I got cardiac disease. So in the case of ALS, neurofilament levels rising aggressively in my blood shows that my neuron is being attacked. So what we show in this program is survival that was concordant with both the rescue and the AHEALY program in long-term open label follow-up. So we have clinical worsening in both programs. We have preserved function in open label. We have neurofilament in HEALY, and we have survival in the open label studies that that are concordant. And so you asked a minute ago about what's the next steps. Yes, we are planning a phase 3. That phase 3 will be a survival program. So specifically, time to event. So we're taking a page from cardiology mortality studies and to some degree oncology studies, and we're basically putting patients in this program, and the event is, in this case, whether or not I die, with a secondary endpoint of whether or not I need permanently assisted ventilation. And we are literally looking for a mortality benefit with CNM-Au8. That's designed to replicate what we saw in the phase 2. Now, some regulatory bodies will require that phase 3 to be concluded, namely in Europe. The EMEA and the European reg authorities per country want there to be this longer study. There is a possibility in some regions of the world, including the United States, that there might be an accelerated approval path, even in parallel to the compassionate use program that the U.S. already allows. So we're presently talking to regulators in the U.S. to see if that is possible.
Right. So, I mean, can you make any estimate of when you expect this to be kind of available in a clinic?
So the phase 3 design is planned to start recruiting subjects in next year. So we expect first patient, first visit to be randomized in the first half of the year. That program is expected to take in its totality, it's about 600 patients we're recruiting in total, unless there's an early mortality signal seen, then that would conclude this. But it's expected to take 2.5 to 3 years for the full recruitment of 600 ALS patients. So for kind of worldwide regulatory availability, that's obviously a few years out. If the US FDA considers that we can apply for what is called in this country accelerated approval, because we have a survival benefit, because we have a biomarker benefit, because we see these two programs, then such an approval is somewhat conditional on the conclusion of the phase 3, but gives patients the ability to try the drug earlier. If that is the case, then we could have those discussions with regulatory authorities over the course of 2025, and possibly there could be an opportunity to have access beyond the compassionate use in 2026. But I've mentioned compassionate use more than once. We have actually 3 compassionate use programs presently. We have one entirely with Harvard, one that we've done ourselves with a number of clinicians, and then one that's been funded by the National Institute of Health in the USA. And so to date, we have about 400 participants that have been able to access CNM-Au8 and that we're following to ascertain their safety and their survival.
For these compassionate use programs, do you have to go through the trial to get into them? Is it something people can request?
There is a protocol that the agency requires. We have to track the patient's clinical benefits and their safety quite appreciably. They don't have to go into the phase 3. Many of the participants that are presently in it, they attempted to get into one of our phase 2 programs in the US, and they could not. They were too sick sometimes, and so they were offered this as a backup plan effectively. There's other participants that couldn't enter the clinical program because it was already full. And then there's yet still another group of participants that were desperate to try something, and their clinician was able to get them into this protocol. So it is a type of clinical program, but I say type with emphasis because it is not a double-blind placebo control. It's basically an opportunity to have compassionate use in such a disease where the uniform mortality for people who have ALS is 2 to 5 years still, despite, many decades of attempts to solve this problem. In much of the world, there's only one, or in some cases, 2 drugs one can try, neither of which are certainly able to solve the problem in ALS.
Yes. Yeah, the neurodegenerative diseases in general seem to be very difficult to solve, and we have not made any progress, or very limited progress, in decades. So this looks really exciting, very interesting. Okay, thank you both so much for joining us. That was really good. Where can people go to get more information and to follow the trials that are ongoing?
Go to clene.com. So www.clene.com. Mark mentioned earlier the name Clene. It's the Anglo-Saxon spelling before the French conquest of 1066 added an A, just as a small little origin of word lesson for your viewers. But clene.com, CLENE.com.
Okay, thank you so much. It's been great talking to you.
Nice meeting you, Richard.
Yeah,
Pleasure. Thank you.
Pleasure.